Good stuff.
Let's get started. So yeah, I shouted out on LinkedIn that this is our first time doing this post webinar, but Matt had the great idea to sit down and do kind of an audio Q&A so that we could have a little back and forth, share more than one opinion as we answer questions, kind of knock through them, and then we will, as you are watching it right now, as you know, we posted it in a LinkedIn group and to social media and everything else. So thank you for popping in and listening to this Q&A stuff. And with that, any other opening thoughts, or should we get started, Matt?
I think that's it. The goal of this is, hopefully no one's watching this unless they also either attended the webinar or signed up and got the video recording and got to watch it. Because most of these questions came from participants in the webinar, during the webinar. We had over 100 questions. We tried to answer a bunch on the fly throughout the webinar live, but didn't have time to answer all. So Kelly and I are going to browse through these, and there are so many questions. We're going to try to hit them one at a time. We may give short answers to some, long answers to others. And as great as we are at what we do, we may not have answers to all of them. So we'll try to at least give the feedback we can, point them in the right direction, whether it's something we have a direct answer or just some suggestions to.
And this is also where we're going to follow up in the LinkedIn group with some of these and post answers to individual questions or groups. If we had like a bunch of people ask about a specific scanner, so we'll post that together. That way, Lindsay and Larry or any of our co-panelists from future webinars can hop in and add their content. You can share your opinion as well if you've had some experience with anything, and continue the conversation in the LinkedIn group, which will be awesome.
And we figured it would be easiest, instead of having all the panelists and guests and everybody on to answer these questions, that Kelly and I, as the co-hosts, would just walk through them one at a time. And there are some specific questions in here that people had directly to a guest. So you're welcome. Again, find them on LinkedIn. These people are engaging, they're active, they'll connect with you if you have specific questions for them that don't get answered today. But let's just start rolling through these. So in fact, number one was directed toward Lindsay because she's a user of the BLK scanner. This question was, can you explain what the BLK laser scanner is and how you use it, why you use it, why is it best for your industry compared to other scanners? So I'll take a first shot at this one. The BLK is one of the entry-level terrestrial scanners that sits on a tripod, like we talked about in the webinar. It measures data with a laser as well as takes some images. Lindsay is in the residential market for the most part. So it was a great entry-level scanner for her for smaller spaces. So that's kind of why she mentioned she uses that one. And again, it is the entry-level terrestrial scanner. So there's my quick summary to that question. And then we'll move on to number two.
Yeah. So where or how would you rate the NavVis scanner? So we've got some experience with both of them. Matt, have you ever messed with the NavVis scanners?
Not hands-on doing the scanning myself, but I have played with some of the data from them as well as some other carts like it. So I'll let you take a shot at this one.
Well, of course, one has to specify which NavVis scanner now, which that's relatively new. In the past, they've always had cart systems, and they've iterated on that over the years. And the general rule of thumb about the cart systems is they tend to fit in between your kind of traditional handheld or carry mobile systems and your terrestrial systems in terms of accuracy. That's because you literally have a wheel rolling on the ground, and you can help use that to control drift, which is what all SLAM systems suffer from. And drift is basically, over time, the measurement error chains and compounds. And so over the course of, 200 or 300 feet, you might be inches off.
Yeah.
Several inches off, even a foot off with a traditional handheld SLAM scanner. The carts do a much better job of managing that drift because that wheel gives them rotation. So they have very good distance on path of travel.
Yeah.
But yeah, the data is kind of in between what you would expect out of like a GeoSLAM or a BLK to go or things like that, and a terrestrial scanner.
So really, yeah.
Yeah, go ahead.
Yeah. So really, if you're talking, mobile, you're trying to get the best quality you can without being in a static scanner. Those carts are probably one of your best options. But then you also have the flip side of it that, those carts are pretty expensive.
And
They're
they're
a
hard to get
couple.
upstairs.
Yeah, yeah. They're a couple $100,000 or something, versus a handheld GeoSlam or BLK or, in the 30-40K range, something like that. And then the terrestrial scanners are the highest quality, most accurate data you can get, but you're not walking through capturing it fast on the go. So again, this comes back to one of those first tips we talked about in the webinar is it really depends on your company, your use case. Are you a company who does a ton of small, low-end, architectural jobs, or are you doing high-end, large, manufacturing, and you need really tight accuracies? All of those factors come into play when you're picking hardware.
Yeah, and just some other quick differences. Mobile scanners, aside from the accuracy, you tend to get much better coverage because you're effectively scanning from millions of different positions along the path. But you typically have lower density overall, though you don't have as many hotspots like you get with terrestrial scanners.
Yep.
And you know, and again, the backpack ones tend to be the most mobile, or the handheld ones tend to be the most mobile. Cart ones have some limitations, obviously. Can't use those on the job site typically just because of stuff on the floor
Yep.
or stairs. And then you're back to that terrestrial scanners. But and then
Yeah.
we've got a question or two questions that are queued up perfectly for you because you've got a lot more seat time with these than I do. So we had two questions. Can you give us a little more info on the Matterport and talk about the Matterport and how it, whether it scans outdoors?
Yep. And again, I think even as we're just getting started in these questions, I think we're going to move a little quicker through some of them just for the sake of those of you trying to watch this Q&A. Again, we're trying to hit like 100 questions, so we're going to move through them a little faster. And again, if you want some real detailed information, or you want to give us a call, or you want to email, you want to talk through something specific, feel free to do so. But these will kind of move through a little faster. So Matterport, like we just talked about, you gotta think about your use case. If you're on small architectural, I would say look into Matterport. If you want a portfolio virtual tour of a closed out project, I would say look at Matterport. And again, if you want to find some information about their hardware, honestly, just go Google them, look at their site. They have some good examples. You can download some data. I'd say that's your best use case. Can it be used outside? Yes, but only in low lit environments. You're not going to want to do it in the dark, and you can't do it when there's direct sunlight, but we have had some success doing it when it's kind of dusk. The sun's not directly out, but it's still light enough to see. We've had some success outdoors with it in that scenario. We also have a hardware question on Trimble. Have we used the Trimble scanners? Personally, we have not. We've used some Trimble GPS total station, but we don't really have much hands-on scanner experience with the Trimble.
The one thing I'd say is the Trimble is a kind of an interesting blend, and a lot of the questions contrasted it with the Faro. So, the big difference is Trimble is more survey focused as a company. So where at the Trimble, you can set up on control points, you can do some in-field registration. Their perspective app's got some stuff to help you do that. I think, so they're much more robust on that side than the Faro is. The Faro has some other advantages in terms of reflectivity on certain surfaces. Again, you got to choose the right tool for the job. Whether one is better than the other, it depends on the job.
Yeah, which also is into the one of the next questions. We had a few there just asking if we had experience or feedback on the Trimble units, the X7. I've heard it's a decent scanner. We've seen some trial stuff, but no hands-on experience to answer that. So the next though was we are looking for a lower tech scanner for smaller, quick deployment and processing. What do you recommend? Same answer there. It really depends on what do you mean by smaller scanner, quicker to deployment? Is it like mechanical rooms that need 3 scans, or by smaller, quicker deployment, do you still mean interior office spaces and such? I would say the couple to look at would be your lowest end BLK, Your next would be, looking between, maybe looking into the Trimble, looking at Pharaoh's S series. Those are kind of the entry level couple scanners. And then you've got Topcon, you've got Leica, RTC 360, but and as you keep going up to those bigger units, the price climbs, the size climbs. So
well, a great reference for this, if you guys don't know about it, there is a laser scanning forum. So if you search for laser scanning forum, you'll find it, and that's a great place to ask a bunch of people what their opinions are on different bits of kit.
Mm-hmm. Oh. Let's see. We had somebody say they've used SLAM LiDAR. Is this different? We're
Yes.
mostly talking about a little bit of everything.
Yeah. But SLAM, fundamentally SLAM is simultaneous localization and mapping, and it's the core technology behind any of the mobile scanners that we talked about earlier. You don't use SLAM for terrestrial, you use SLAM for mobile. So if you've done mobile, you've used SLAM, but it is LiDAR. And if you've done, if you're terrestrial, it's just LiDAR with C2C or other registration.
Next question was asking if we have a matrix that shows what scanner is good for what application. A good idea, but I don't have anything on hand like that. I think the best bet would be, like you mentioned, maybe laser scanning forum, or reaching out to one of us directly and asking about your specific application and getting someone who understands the hardwares to make a recommendation.
Or take a peek at the US IBD. That's the US Institute of Building Documentation. We'll probably reference it later. They actually have a project right now where they're working on a kind of third-party soup to nuts comparison of different laser scanners. So that's not published yet, but it probably will be in a couple months. And that should help people kind of sort those things out in a good way. So take a look, US IBD, super cheap to become a member, and you get access to all the materials. So
perfect. Next question. I'm going to keep pushing. Which units work best with Autodesk software or with GIS and Esri? Again, most of these scanners, you can convert different scan file types. No matter what you capture it with, you can turn it into a point cloud format that gets into recap that goes into the Autodesk suite. So it doesn't matter if you use the BLK or a backpack or whatever, you'll end up being able to use the data. So it's more about what it is you're still trying to capture, which was the second part of that question, was for scanning industrial facilities such as water treatment plants, pump stations, et cetera. So I think with that focus, you're going to want to look at the mid-range or to the high-range scanners. You won't want to look at the entry level, because when you're talking about plants and facilities, you've got a lot of detail. You're looking at piping and steel and structure. You're going to want something that's a decent quality level. So that'd be my suggestion. Look mid-range to start your search.
Yeah, and we're kind of jumping into the next line of questions, which are kind of also scanner selection. And in the interest of time, what I'd say is, we've got a couple of dense stainless steel piping, industrial, pulp, paper, manufacturing, stainless steel piping again. So to reiterate the point Matt just made. It is very specific, but any of these kind of high accuracy use cases, you're probably wanting to get a scanner with a DAC, dual axis compensator, so you get good levelness, or you'll need a secondary piece of equipment to ensure that you're getting good levelness on the job. But you're really wanting stuff that picks up reflections really, really well. I know from experience, Faro and Leica scanners, the higher end Leica scanners do great with those kind of surfaces, better than most. So take a look at those.
And one thing I'll throw out there, again, just being that one of our main uses is the Faro scanners, there's even some things to do within an individual scanner to change their, a lot of these scanners, you can change the settings of quality capture, which is its sampling points, and the resolution, which is the density of the points. And the Faros also have a low power setting, a mid power setting, and a high power setting for if you're trying to capture close reflective surfaces or, building faces really far away. So even within that scanner, if you don't change those settings properly based on your proximity and what it is you're capturing, that will make a difference. So even consider with the tool you have, remembering, oh yeah, I'm close to this reflective object. I should go in and change my settings to that near distance and up my quality so it checks things better. So even think about the settings no matter what scanner you are using.
Yeah. Now we've got an above ceiling question here. Basically, can utilities in the ceiling space be scanned? And just remember, scanners are based on lasers, which are line of sight. So you can scan, but you have to pop ceiling tiles. You have to get the scanner above ceiling. And that does dramatically limit your field of view and line of sight. So you typically have to do a lot more individual locations above the ceiling than you would have to do below the ceiling to capture the same space. And in terms of can the size of the utilities be determined, it's a laser scan. So yes, you can get the size of anything you can scan because it will be very dimensionally accurately captured.
And this is one of those scopes that is one of the more challenging scanning projects for the field side, for the registration side, and for the modeling side. But it's also one of the most valuable because if you're not scanning and you're doing a complex above ceiling, we just did a project, we just quoted another. This is a need out there, and it's one of the best ways to do it because by the time you pop ceiling tiles and you capture scans, you're able to see pieces of pipe and make some connections in between certain areas that if you try to do it without scanning, you're going to take a long time. You have no idea what direction pipes are going. You're making a lot of assumptions. So it is still one of the best methods to do the above ceiling. But it does take a lot of extra time for the capture because another thing you have to think about is you have to scan at the floor level and then you have to scan up by the ceiling tile to get some overlap. And then you have to put it above the ceiling to get the above. So you're doing, 3 or 4 times the amount of scans than if you're just doing the ground floor level. So you just have to realize the amount of work that goes into it before, making assumptions. So again, if you haven't done it, but you're getting into it, talk with somebody who can give you some advice there.
Now we've got a fastball here from a name I recognize, good old Chris Kirchhoff, about which scanners get the best return from glass, which the answer is basically none of them because, of course, glass is transparent to light, as Chris knows. But there's a lot of really good tips and tricks on this. One of the things we used to do is just take 8.5 by 11 white sheets of paper and just there was some nice 3M sticky stuff that didn't leave residue, and we just spray the back of them, slap them on the glass. And while you wouldn't get the whole glass, you would at least get surface of glass in the, where the paper was. I've seen people spray mixed baby powder and alcohol, and you can spray that on the window, and the baby powder will basically make it not transparent, to the light and get a return. There's all sorts of kind of crazy tricks for it, but the short answer is it's glass. Light goes through it, or the scanners don't know it's there.
And honestly, out of all the projects we've done over the years, there's been issues of like the glass makes noise in your data and such, but there's not been a lot of cases where we specifically are trying to capture the glass. So typically we just deal with the fact we know there's going to be noise and we clean out that data after the fact. So if that's the scenario, you don't really have to worry about it.
Oh, gosh.
All right. Next one. When do you recommend using targets and when not to? And if you can explain the correct use of them, that would be great. Thank you. So
always use targets. Always use targets.
It's a rare scenario that you want to do a lot of scanning without any targets. Because of the issues we've talked about in the webinar of confirming levelness and different types of issues. I will say there are times that we don't use targets. It's typically smaller jobs. It's typically if there are good solid features of walls and windows and doors and things to utilize in that cloud to cloud registration. That's part that people forget is that even in cloud to cloud registration, it needs good solid features to use. Otherwise, it's going to be cloud to clouding on features that, dirt and ground, you don't want to do it in a natural environment like that. Unless your accuracy need is really small, then it doesn't matter. But for the most part, we would integrate targets. Even if we're doing cloud to cloud, we'll still integrate a sparse amount of targets and tie those in with control or something. But I'd say
it's a
It's
great
the
way to
safest route.
check accuracy. It's a great way to, when stuff goes wrong, you have to fallback. And I mean, I agree. There's definitely jobs where we don't do it because we know we'll be fine. But until you know their scanner, know the process, know everything about it well enough to know you're going to be fine. Anybody that's getting started, I just say always use targets, because the worst thing that happens is you don't need them. And it takes like 10 seconds to hang a couple targets while the scanner's scanning. You're walking around anyway doing the scanner dance. So just hang targets. They're there if you need them.
There's a few more questions on targets that I'm just going to kind of lump together because some of them are around that. When do we use targets? Do we have a video that shows how to use targets? Why use spheres instead of checkerboards? All of these kind of, they all fall within the same, the same answer. We want to use targets. There's benefits to different target types. As far as workflows go, when you're registering, that's really going to depend on your software and all that. One of the benefits to the spheres, again, we mentioned this one in the webinar, but one of the benefits to spheres is you can capture data all the way around it instead of having it sit on a flat surface and you lose the angle of it and it becomes, only usable in a couple scans. Sometimes spheres can be seen for a longer time. And that's one tip there too, is the longer you can keep a single target in different scan setups, the better, because it's using that same sphere or same checkerboard over and over to help reduce the amount of error between different setups. So if you can reuse targets, that's a benefit.
That more or less is the answer to Chris's question here at the end. What are your thoughts on spheres for long-term use targets? That's why you want to use spheres for long-term use targets.
Now, I have two thoughts to that question I was going to throw out. So the spheres, when you're on site and you're using that as a long-term temporary target, I would say that's the best. Then the other question we get, which it's not specifically there, but I feel like it's kind of within that question, is leaving targets or tying back into the same project in the future. We've looked at people setting up little metal plates to resurface spheres to, and then you also can put up, checkerboard targets. Some people will laminate them and stick them up as a permanent to come back to. So there's kind of different options if you're actually talking about leaving targets at the site. All right. I think we're going to pass on through the rest of the questions on targets. That was most of them lumped in there. And now we are into some talking about reflections and refractions and messes and how to deal with cleanup. So let's see this first one here.
I think, really the first two are all about glazing and dealing with glazing. And, the short answer is, we touched on this in the webinar, right? Because if you're using cloud-to-cloud registration, reflections and refracted data are extremely dangerous because they will create false surfaces and the registration algorithms don't know it's a bad surface. So if you're using cloud-to-cloud, you really want to clean those up before registration, which rules out using something like Recap for registration unless you first clean them up in a different software. But basically, you're going to want to go in and basically window all the windows and mirrors and delete the data that you see through them. And there's not a great, quick, easy way to do it. I've seen some people have some success with filtering data based on the intensity value, because stuff through windows or off mirrors tends to be low intensity. But it's still a manual cleanup process. But you just got to do it if you're doing C2C.
And there's kind of, it's really just a laborious process. If you have a lot of scans that need to be cleaned, there's no way to really get around it. And there's two ways. You either are getting in the individual scan view from the bubble view, and you're actually in the view from the bubble view and you're mapping around a window and making a selection there and then deleting it. Or you're getting in the 3D data and looking at it from the side and chopping it off, where the reflection is happening. That's really how you're going to do it out of individual scans. And again, that's important if you're registering with cloud to cloud. If you're with targeted, you can just register and kind of ignore that data unless you need it cleaned out because the client wants to use the point cloud directly, or if you're sending it off to someone who's going to model it or something like that, and that's going to cause confusion, and they're going to model in walls in the middle of the room. You may want to clean it out, or at least let them know there's reflections. So I think communication and who's getting and using the data is another thing to think about there.
And of course, glass isn't the only thing that can cause reflections or refractions. I think I showed that data set in the webinar that looked like the birds were attacking the building because the ceiling tiles were reflective. But mechanical stuff, we have a question on what settings to use so mech does not explode into reflectance garbage. And I think, to your point, every scanner has different settings. Faro has some settings Matt talked about earlier that you can use to tweak for things like that. I know TopCon scanners, the ones that we're using right now, have some settings for that, low power, high power, all those kind of things, quality settings. But you really kind of need to experiment because every scanner type will be a little bit different, and you've kind of got to figure out what settings work for you. And again, laser scanning forums, if you've got scanner X, hop on laser scanning forum or hop in a LinkedIn group that we're setting up and say like, hey, I've got this scanner, what settings should I try? And let's see if we can give you an answer. But there's no generic answer.
Yeah. All right. I think we're kind of through some of the noise questions. We'll move into the next area, and I'll let you take the first one.
Oh, is there any possibility to use a DAC with a moving environment? Yes, no. So the short answer is we talked about dual axis compensation. That is fundamentally a stationary technology. So that only works on total stations and terrestrial laser scanners. As soon as you're moving, you are relegated to an IMU, which is why all mobile scanners use the IMU for
which I think the rest of that question then goes into it. Are we able to scan while on a moving object? So on a ship. Yeah. So are there challenges with scanning on a ship that is moving in the water?
So this is where you get into like really fun stuff, because here's the thing, and this is the challenge, like trying to take a mobile scanner onto a ship moving on the water is a nightmare because you have two different movements, right? There's the movement of the ship, and then there's the movement of you within the ship, which you have to isolate the two because you don't want the two combining. That's going to give you bad data. So mobile scanners do not work on a ship floating on the water, full stop. Don't do it. Don't try it. It's a disaster.
So your best bet there is now back to our other important point of, should we use targets?
Yes. Terrestrial scanners and targets are the way to go on a ship, and you basically disable, if it's floating on the water, you basically disable the DAC or the IMU to some extent, though leaving the IMU on just so you know what up is useful, but you are going to ignore that during registration for the most part. It's a much more complex registration because it's a 6D, not a 4D problem. We can go into that on the 301 class maybe. But yeah, ships, moving objects. Now, if the ship's in a dry dock, it's a building. It's stationary. Mobile scanners, everything's fine. Go to town. But if it's actually floating on the water or like scanning an airplane, it can't use a mobile scanner for that.
Yeah,
if it's moving.
Yep. And similar, not a ship, but another question about instability or shaking is, do you have any trouble with shaking or instability when using an elevated tripod for high level scans or above ceiling? You can. If you're outdoors and there's wind, the higher up you are, the more drift you can have with the scanner itself. Same with, we've used man lifts inside of warehouses or at facilities. And, if you're in the man lift and the scanner is in the man lift and you're not absolutely sitting still, you shift your body a little, the man lift's moving. So your best bet is to either use the tall tripod with stability and you make sure nobody's moving it, there's not vibration around it or whatever. Or if you put it in the man lift, you're either sitting underneath it or really still. We've done that before. Or if you have the option of, and there's safety, precautions at all different types of projects and sites, but you could strap your tripod in the man lift and have it lifted by itself and then use a remote start. If your scanner has that capability with an iPad or an iPhone or a computer to connect to it, that might be another option for you.
And this is actually one of those areas where using multiple sensors makes a lot of sense because you can collect all the lower down data with the terrestrial scanner to ensure you've got really tight accuracy. But if your project allows it, that's where a mobile scanner is great, because mobile scanners are already robust against small movements. That's kind of what they're designed to handle, is somebody walking. So if you can use a mobile scanner for the high up stuff, and then just make sure you have tight, do it in small little loops so that you can then register that down to the terrestrial scan data. So there's a good pro tip there.
Yeah.
Oh.
All right. Let's see. Is the inclinometer in the Faro scanner good enough to level the scanner, or should you use an external leveling device? I would say from our experience using them, we've run into both. We've had times that we used it without external devices for actually doing the registration, and we've taken check shots to confirm. So in some trialing, we've used it successfully. However, like we also talked about in the webinar, if you're doing, the more scans you add into that and the longer distance you go and it's trying to register to each other, I think the more chance for error. What's your thought, Kelly?
Yeah, I mean, it depends on the job. And again, any IMU based levelness its accuracy is relative to how level the scanner is. So again, if you mount a Faro on a Tribrach and level the Tribrach, the levelness that the IMU can deliver is much better than if you just set it on a tripod, don't bother leveling the tripod, and the thing's leaning at 3 degrees. Well, you'll get much worse levelness out of that scan from the same scanner, because IMUs are relative to how far off they are. So, there's things you can do to make it better, but, at some point, anything without a DAC, if you get big enough with enough scans chained, you're going to want some other mechanism of levelness to establish that.
And I think one of the great points we talked about in the webinar, which just this really answers everything to do with targeting and a secondary device. And, if it's a critical job, it's better to just do the extra step in the field than wonder if it will work and spend all this time and then end up finding out, down the road, I registered it, I modeled it, it's not level, I didn't know, I have to redo the project, I have to try, there's so many things that can go wrong that it's better to take the one step in the beginning to make sure you're going to come out with good data. And again, everybody who's ever scanned has learned the hard way one time or another. So it's going to happen at some point, I'm sure, which is why, those of us that have been doing it for a long time can stress that is, look, we've tried to make shortcuts in the past. We learned the hard way in the beginning. We didn't have someone giving us all this Q&A, back in the day when you're first getting into it, there weren't a lot of people that had this information to share. Everybody's learning it on the go. Now that we're here and we've done that, we want to tell you, don't learn the hard way. Do it right the first time. Don't take the shortcuts. So, it's recommended.
Strongly.
Tribrach, how does a Tribrach work? Would you use an auto leveling Tribrach? There's a couple questions here about decent tripods, etc. So the Tribrach is that survey piece that goes on top of a traditional large survey tripod. So if you're looking for something sturdy in the field that you don't want moving around, there's a lot of tripod types. That Tribrach is that piece that goes on top, and there are adapters that then go into the Tribrach that hold the scanner.
Exactly. And you can mount any scanner on a Tribrach. You just have to find the right adapter. It's a little 5/8 inch screw. It's super easy to mount onto the tripod typically. And there's adapters if you have a smaller, like a photography tripod. And then there's one we skipped that I do think we should talk about, which is calibration.
Sure.
Calibrations that can be done by the user and not the manufacturer. So two things, temperature matters for a scanner. And so the kind of calibrations you can kind of do on your own are things that calibrate the instrument to the environment. And one of the big ones to do if you're, in Arizona or anywhere where there's a big temperature shift or you're moving from indoors to outdoors while you're scanning, is to make sure that the instrument has time to adjust to the temperature if there's a big temperature change. And occasionally you'll want to either manually run or restart the scanner so that it recalibrates to the temperature. And that's super important because the temperature actually does affect the measurements, not too surprisingly, because you're dealing with such tiny bits of time when you're taking these measurements. So, but outside of that, you need a facility that has an extremely accurate mechanism if you want to recalibrate the actual scanner measurement, and you got to send that into the manufacturer.
Yep.
Yeah.
Perfect.
Survey control.
All right, we're into the next set of questions. We have these separated out by different categories, so we're kind of through that one into the next area, talking about control points, talking about survey. So can we explain survey control? This we also, I mean, we hit a bit in the webinar, so if you want to rewatch the webinar, we explained a little more detail there, but essentially survey control is it's a traditional survey methodology of using a total station to set much more accurate points at longer distances. So instead of 100 setups around a building, we can set up at each corner, shoot a really long distance, and we know the exact XYZs at the end of the building, and we can use that to help control the whole site. And there's kind of two purposes even for survey control. One is helping the overall registration of the scans actually fit together better and be more accurate. And two, we can use that to tie it into actual coordinate systems, shooting benchmarks or shooting property boundaries, or site control for a construction job. Every job has some type of survey on it, so you can tie into those coordinates. So your models, your scans, your drawing, your drone, everything has the same coordinates, which makes the job a lot easier back in the office when you're dealing between project managers and construction companies and whatever. Anything they utilize now will have the same coordinates.
Because if you want to have some fun, have 3 different people take a non-controlled scan and try and align it to the model. And then load those 3 scans into the same Revit model and see how far off all 3 people were from each other. And you will be fascinated by how differently 3 different people will line the scans up. The only way to reliably get the model and the scans to line up is to use some kind of control.
Yep.
So,
yeah. Becomes critical on most projects.
Yeah. And can recap be used to orient point clouds? Yes, it can. We can orient. They've got some control point stuff, so you can use recap for that.
Which also, I think it has to be Recap Pro. Is that correct?
That is true. Yes, it does.
So a lot of you out there may have the free version of Recap that comes with a suite, or you might have Pro. But if you notice there are or aren't certain features, that could be the thing to check is, do you have the Pro version? It's not a big cost if you don't, but.
We've got a question here that's a tea leaf question. It's, what is Autodesk going to do now that it's, kind of end of lifing or not developing Recap? The answer is only God knows. And we will all just be waiting and seeing.
There we go. I think we've been asking that question for a couple years now.
Yeah. If you know the answer, please call. But yeah, large amounts of scanning. Which is the best procedure to join the clouds? Oh, so this is kind of back to our registration stuff from earlier. Yeah. So I think short answer is there is no one best. You should use a mixture of all 3 because that gives you the best redundancy, reliability, and accuracy. Full stop.
And next question was about cloud to cloud again. Same scenario. We already answered that one, but a lot of people have the same questions. It really is around hardware choice, controlling processes. So I think just go back and listen to the webinar about some of those specifics as well as what we already mentioned here.
Yeah. Oh, we've got a best registration software question, man. So I'm going to go back. We were talking about scanners. There's not a, best is a best is in the eye of the beholder. So, I know some people that love Recap because it's super simple and easy to use, and they do small jobs and it works really well. So for them, Recap is the best registration software, right? I wouldn't even call Recap a registration software because I refuse to use it for that purpose because of its limitations. When I was in practice doing laser scanning, the software, my go-to software was like a Cyclone because it's, it has just an absurdly robust number of options, but it's also incredibly tedious to learn and use. Like the user interface
and the most expensive.
So it's like, I think again, right, Matt, the trick is balancing out your needs, the kind of projects you work on, and the kind of tools that you have, and figuring out what delivers results that are good enough for you, and then choosing that solution. And depending
Yeah.
on the scanner and everything else. There
Yep.
are a lot of good registration tools out there, though.
Yeah. And I think that's part of it too, is like the software choice may also be aligned with the hardware choice, because certain softwares don't take the native of one hardware versus the other, or you need to take it in there first anyways. Well, then maybe you just register in there. There's other reasons to pick the registration software. But I think in general, the software provided by the manufacturer is probably the best option for whatever hardware you pick. If you're going with a Leica scanner, go with their software. If you're going with a Faro scanner, go with Scene. If you're going with, I would say it's probably the best route to go. And if for some reason you have a really specific use case, then maybe you get an additional piece because it's good at a certain thing.
Well, a lot of the firms that have been doing it for years, they own multiple instruments from multiple vendors, and therefore they have multiple registration softwares. And so, you'll see them using different things for different jobs. So, there's a lot of capable enough solutions out there that aren't NCAP. Sorry, auditors. It's true.
Let's see.
Ooh, traverse a site with scanners, or do you just scanners to check into known control? So, I think from our dialogue, you might have noticed that Matt and I are both big fans of control and having control on a job, whether that's traversed with the scanner, which some scanners are capable of, some like a P-Series, TopCon scanners, are capable of doing infield. I think the Trimble X7 is capable of doing infield, as is the X10 or whatever the prior one is.
Mm-hmm.
Are all capable of doing infield survey. You can actually resection or occupy backsite with the scanner in the field. And that's one of the reasons I love those scanners, because I do it a lot, because I think it's easier than having to have two instruments, having to carry a total station and a scanner. But again, for really large projects, there's range limitations, and that's where you really want a total station to do it.
Yeah.
So.
Yeah, and again, I think it comes down to project type, because those total station scanner combos also are not a good option if you're doing a high volume interior space. There's different options depending on if you're doing outdoor or indoor, or need control points, or need to shoot targets, or it's a whole mix. So depends on that as well.
Yeah. And then, of course, can you show a good way to match scans with real coordinates? Survey control. Yeah. So.
And the actual process to do that is going to be different depending on your software. But again, one of the simplest ways, people put up checkerboard stickers that have the black and white. The total station from the surveyor shoots the center point of the black and white targets. And then in the registration software, we can align the data set to those. That is the typical way of getting the scan job onto real coordinates.
Yeah. What is the recommended spec? Oh, computer specs.
All right, we're into computer stuff now.
Yeah, so I showed this project in the webinar, which is, for the record, 175 scans with a ZNF 5016. So really nice, high speed, very dense, beautiful photographs on that scanner. And but I'm running a shout out to Buck Davis. I've got a BIM box here, but it's an overclocked i9 processor running at 5.2 gigahertz with 64 gigs of RAM. I've got two GTX 1080s, TIs. So it's a super high spec computer. So I've run jobs with 1,000 scans on here, and it pumps like a champ. But scans are pretty resource intensive, and
they are.
Yeah, the bigger the job is, the better the computer you're going to need. But on the other hand, a Surface Pro laptop, and I do stuff with Revit and laser scans on that all the time.
Yeah. I would say, as an overall thought, if you're doing a lot of scanning and modeling jobs, I would just get the nice computer and deal with it. Like a lot of people in the industry are trying to just barely get what's good enough, and they try to go with like what's just under, okay, for a couple extra $1,000, like get the extra RAM, get the extra hard drive space, because at some point you're going to do a job that extra space saves you headaches. You had extra hard drive space, so your process didn't cancel and say, oh, you ran out of room, or there's just things that you'll run into if you don't get the extra space and the extra power that you'll regret in the future, and that savings will save you.
It'll pay itself. I mean, like I'll give you a simple example. Our software, if you're running it off a local SSD, it runs about 70% faster than if you're running it off of an external HDD. Like that's 70% improvement in performance just from having, but you got to go spring for that 2 terabyte or 4 terabyte internal SSD.
Yeah.
But yeah, I mean, and I loved your suggestion though, because like, for instance, doing the scan to BIM modeling in Revit has very different needs than doing the processing of the point cloud. In the sense that one of them is primarily single-threaded, fastest possible speed, which is the modeling, scan to BIM modeling, because Revit, while it is multi-threaded, minimum benefits from it. So, if you've got multiple people, if you're a firm that's large enough, target the use case for it, and have a scan to BIM computer, and then have your registration and processing computer, which will have oodles and oodles of threads, oodles and oodles of RAM, and oodles and oodles of hard drive space. But other things, the graphics card isn't quite as important for that, and the single processor speed isn't as important for that. So get your massive 64 core Threadripper or Xeons or whatever. So
and that's the best recommendation I have, is really use multiple setups. If you're a big company and you're helping make the decision of what to buy for your department or something, don't make everybody have the same thing. Everybody that's doing the modeling may have one spec, but build a specific computer that is for that initial data dump and crunching. Or if you're also doing drone, build something that's for processing that. But again, there's entry entry-level people that are looking to do everything with one machine, and it is still doable. You can do it. People can even do it from a laptop. There are going to be times that you're going to have headaches and, slam your computer down and whatnot, just because it is a lot of data when you get into big projects, and it will crunch. There are times we do exports and with as good of computers we have, it'll sit there for a day or two, and we have, $10,000 desktops or whatever. So there are processes that unfortunately right now you just can't get around. And you may run into that on large jobs.
Yeah. Oh, and Revit, we have a question on Revit limitations. The recap engine has gone a long way in making Revit usable with point clouds, but, all of these things have their limitation. And what I'd say is, like, if you're working in Revit, it's wise to break up your scans into chunks and areas. And you can do that either by unifying and then sectioning stuff off. I strongly prefer working with structured data for a whole host of reasons. But, in that case, you just group scans into, here's, scans on the second floor, scans on the third floor, scans in wing 1, wing 2, wing 3 on the third floor. But if you kind of break them up into chunks that, roughly correlate to where people and how people are working, so they don't have to load everything, I mean, that makes Revit extremely scalable. And, I've used Revit on jobs that have 3 terabytes of scan data. 3 terabytes of scan data. Nobody loaded all 3 terabytes at once.
No?
That's batshit crazy. No, but they, what they did is they loaded level 1, wing 1 of the hospital and looked at the scan data over there when they were working on it. When they moved to wing 2, they turned off wing 1 and turned on wing 2, just like work sets in Revit.
And I think one of the important parts there becomes data management. It becomes, making sure that you have the files named properly, that if someone goes and makes a revision or something, that they don't, load in the wrong point cloud, or nobody is pinning them and unpinning them, or, making sure things are set up in the beginning and not getting moved. That becomes important when you're talking about data management.
Oh, yeah. Now I've got, this is my favorite question of all of them. So shout out to, let's see, is it Brennan Krochenko? How often do you end up needing to deviate from your standard workflow, and how do you adapt? So, man, I want to hear your answer, but Matt, my quick answer is standard workflow is a guideline, and I cannot say that I have used the same workflow on any one job or any
What's
two.
a standard workflow?
Ever. Because every job is different. There's always little things and tweaks you have to make. And I mean, I worked on probably, God, I think when I was running the group at Beck, I think we were up to like 175 jobs in my tenure there with scanning and scan to BIM. And I would say no two of those jobs had the identical workflow. There was always some part we had to ad lib somewhere.
Yeah. Yeah. And I would say the same thing. And even what's different from us and your experience at Beck is like, you know, you guys, I think, correct me if I'm wrong, but are very focused on your construction jobs and the integration of data into them. And is that correct? Or,
Well, we were design build, right? So we also had an
yeah.
architecture firm. So we had kind of three types of jobs. We had the design servicing jobs where we just did the design as a company and we were servicing architects. Basically, we had the design build jobs, which were kind of very unique. And then we had just the construction jobs where we were kind of doing more construction centric folks. But yeah, I mean, overall, it was architect or construction or both.
Yeah. And that's what's even different when you get into, if you're a service provider, which is where we came from, and you're supporting projects across all industries. Now you're really talking about, there is no standard workflow because, you know, every project we get pulled into is different. Hey, we have this gold mine that we want to scan and it's a mile of underground tunnel. Hey, we have this shipping boat, you know, in Alaska that we want to scan and we need to capture down inside of it in these little spaces. And, you know, hey, we have this hotel, you know, every project is different, and how you're going to capture it, how you're going to control it, how you're going to break up the data, how you're going to register it. All of those things become so different from each other that what it really takes is understanding each area of capture and control and process. You have to understand the different methods available there to then approach a single job and say, okay, how big is this job? What's the accuracy need? How am I going to collect it? And then we can plan around all of those different scenarios. So same for you. If you're, depending on your industry, your hardware, whatever, you're going to plan each job differently depending on the need.
And that in a nutshell is why we're doing these classes and why this is such a tough thing for people to get into, because this is not, this is not something where there really is a good standard workflow. And as long as you follow all the steps and check the boxes, you're going to get good results every time. That's just not where we're at.
It is a lot easier, I would say, to be close to that if you're a company that does the same types of projects and you're looking at implementing this and using it on just architectural jobs. Like, okay, now you're a little closer to being able to build out a standard process to follow. How you're going to do your control on jobs typically, and how you're going to split up your data and name it because your design team wants the inside versus the outside. You can start to build out some certain workflows there if that is the case. But a lot of people are on very diverse project types, even as a construction company or something, or even as an architect, how you approach an airport versus a hospital versus an office space. All of those are going to be different in how you capture it, the modeling difficulties, the registration issues. Is there the above ceiling? There's still going to be a lot of variation.
Yeah, absolutely. And this, you've got it highlighted. So there was a question about the LOA specifications, which is also a shout out to the US IBD. So while there are certainly not standard, I think, processes that you can just rely on at a high, at a high level on every job, I think there's some really great tools out there in the industry, and we're actually going to be showing one in the Scan to BIM 201 class that's coming up on Thursday this week. That is kind of like it's a checklist that Jacob Dalbora uses with his customers to make sure he understands their needs so that they do the right field capture and practices. But US IBD has some. Again, if you sign up, become a member, it's like $250 or something a year. I mean, it's super cheap. But they have LOA specifications, all this other stuff that you can download, RFP, templates that are there to kind of hopefully help you be more successful in understanding what you need to do to be successful on the job, and give you some tools to kind of walk through that process so you don't have to make your own. So definitely go take a look at their site. Strongly recommend it.
Yeah.
Meshes.
Perfect.
Matt, this
All
one's you.
right.
This one's all you. I hate meshes.
Yeah, I mean, honestly, yeah, one of the questions is talking about bringing meshes into Revit. Um, I think it's not something that people do often. I think there is a process for it. I believe we've done it in the past. Honestly, it's been so long, I couldn't tell you specific details on meshes into Revit. I know that there are some softwares out there that are working on improving the ability to mesh point clouds, segment different features within the mesh, and try to bring that in as a base within Revit. I think you still want to be careful there, though, because even if you could mesh data and bring it into Revit, now you still don't have internal Revit families and things that are going to operate the way a lot of people want them to within Revit. So I think your use case for worrying about meshing into Revit, I feel like is limited as to a small amount of use cases, at least from my understanding.
Yeah. In general, just use the points. You're better off 9 times out of 10.
Yeah.
Totally agree.
We got a question here about if the laws vary by state. And the answer is yes. We don't have, I wouldn't say we have an answer here to tell you what states have what laws. You kind of have to look into it per state. But I think the main laws around this technology, around drones, around laser scanners, around total stations and GPS and surveying practices are you do have to look into what that state requirement is, because some states are trying to lock down and say scanning is survey. Now, depending on the use case of the scanner, they may allow you to do it. They may, come into issue. I think one that I've heard is North Carolina, I think, is on kind of the front end of making certain capture processes require to be signed off by a surveyor. I personally, even though we are a survey company licensed in California, I think that it is still going to be impossible to say that scanning in general is a survey tool, because if you're using it for a floor plan within a building, you're not tying to a boundary. I think there are times that you can use it and not be a surveyor. But there are also times that if you're tying into control and you're getting, you're going to want to be careful, because there are lawsuits going on, of people getting into things they're not supposed to. Same with drone. Don't go flying commercial projects if you don't have pilots and you don't have safety procedures and you don't have authorization to fly. Don't crash your drone on the White House lawn. People are doing things they shouldn't. And they are finding people. So you don't want to be one. Again, this is kind of the same thing I say on the capture side. Don't shortcut yourself in the process. Also, just kind of make sure you're safe. Double check your laws for your state if you feel like you're on that line of potentially getting into a survey practice.
Yeah. And how would you recommend finding a good sales rep? Because I think all the rest of the questions are kind of related to the next webinar, or details about recording stuff, which we can kind of answer at the end, or housekeeping. But this is the last one. How do you find a good sales rep?
That's a good question. I think it depends on what it is you're looking for. Honestly, your easiest route, if you're talking about a scanner or a piece of equipment, is to just contact the company directly, because they then have a process to route the sales inquiry to your local person who can probably meet with you in person or demo hardware. Typically they have a good process set up. So I would say just reach out directly to the inquiry form, through a scanner's website or something like that. And then same on software,
Yeah, this is something Lindsay actually brought up in our pre-call about, sale, like reseller versus
resellers. Yeah.
And I think, I think what we talked about on the pre-call was, if you're a small shop, resellers are great, because they will pay attention to you in a way the manufacturer won't.
Yeah, that's true.
You're a big part of their revenue. On the other hand, if you're a big shop, if you're a large company, there's a lot of advantages to going directly to the manufacturer if they support that, because if you're large enough, you will have their attention. And if you have their attention, it's nice to have that direct line of attention to the actual manufacturer. And I think think it just depends on how big of a business yours is, how many scanners you're likely to buy, because that will determine whether, you know, the manufacturer will love you and talk to you or ignore you. And
Yeah.
and if they're going to ignore you, you might as well go to a reseller because they won't ignore you.
Yeah.
So
And I think even picking the reseller has a couple, you know, there's a couple things to weigh there. One, do you have a good recommendation for someone who seems like a good reseller, but is not local to you? You know, they can still deal with you and be there to support. Or two, you know, are you in the type of industry that you want someone nearby who can help you with some like hands-on training easier? Those are probably two of the things I would weigh. But I would definitely talk to some people who deal with them prior to picking who you're gonna, you know, sign up with, because it'd be good to pick somebody and have that long-term relationship.
emergency equipment loans, there's all sorts of reasons to have a good local reseller when you're dealing with hardware.
Yep.
Software is a
Yep.
lot easier to do long distance, but yeah. All
Yep.
right. Well, I think, you know, we have some questions about the recording stuff. So yeah, it was recorded. So again, like we said at the start, if you somehow find your way here and made it this far, but didn't see the original thing that we're talking about, hop onto the links and register for the first class, and then you'll get the recording for the first class. The next webinar is, of course, this Thursday, which this, I think, will hopefully post the day before. But we'll see when this actually posts, so that may be too late. And then for interested parties, the t-shirt that we were all wearing, if you attend all 3 classes and provide your information, we will send you a t-shirt. So if you make it to 101, 201, and 301, so yeah,
Yep.
make sure you make it to the class on Thursday and the class 2 Thursdays from now, so October 31st or 30th, 31st.
Let's
Is it a
see.
Halloween class?
It's
Man.
the 29th,
29th. All right, I feel better now.
but you were close.
Yeah, well, you know, plus or minus. My apparently my accuracy is plus or minus 2 days.
There you go. There you go.
But
Perfect. Well, we appreciate all the questions, the interest. It's exciting to see the industry growing, and it's also nice to be able to be a part of educating, helping people learn, you know, how to go about getting started, or even if they're in it, how to avoid mistakes, how to increase accuracies. There's so many steps along this process. You know, we know together, Kelly and I, ClearEdge and Nexus and RCN, we're excited to be a part of your journey and guiding you guys along the way, and happy to answer these questions. So hopefully you can make it to the rest of the webinars, and we'll see what comes after that.
amen.
All righty, guys. Thank you.
Thanks.
We'll see you soon. Boom.